Good evening, everyone. Welcome to another Planetarium live stream, and happy August 1st. How's everyone doing today? I am your Planetarium Manager, Patrick Hess, and thanks for tuning in to our 85th live stream. We're so happy to have everyone joining us, and as people are entering, I'd like to remind everybody this is a live stream, so if you're watching on August 1st, 2022 at 6 p.m. Central, then let us know. I love seeing your comments in the comments section, and I'd love to hear where everybody's watching from. And if you have any questions, of course, throughout tonight's stream, be sure to put those in the comments. Also, a special shout out and thank you to our supporting sponsor, MRI Global, for keeping these live streams and many other programs at Union Station going. We're so thankful for your support, and we're so thankful to everybody watching tonight. We've already got a couple people chiming in the comments. We've got Cherry saying, love the flag. Glad you enjoyed, Sherry. We can post a link to download that if you'd like. And we've got Pete Gonzalez saying, doing good. Glad you're doing good, Pete. Thanks for watching tonight. We've got Allison saying, cool, never seen this before. Well, awesome, Allison. We're so happy to have you tuning in. And and this is a great segue for me to say that although this is our 85th live stream, if you're a first-time watcher, we're so happy to have you here. And don't worry, because we've recorded all of our past live streams and they're available on our YouTube channel. That's youtube.com/KCPlanetarium. So Allison and anybody else tuning in for the first time, don't worry, because you can check out all of our past streams. Not just our What's Up live streams from the past few months and about a year now, actually, but back all the way in 2020, we did weekly streams that did deep dives into all sorts of topics for an entire hour. So if you're really bored and want to learn all about space and astronomy, we have curated playlists there of all of our past streams. If you're a returning watcher, thank you, of course, to all of our longtime watchers. And longtime supporters. And actually, I want to give a special shout out to Tammy, who is already commenting saying, hi from Iowa. So sorry we missed you when we were in Kansas City. Hopefully next time. Well, I'm so sorry I missed you too, Tammy. I'm so glad you came to visit, and I appreciate that it was going to be a surprise, but I wasn't there to see you. So definitely next time, give me a shout out, and I'll make sure I'm there to see you. And of course, a special shout out to, I think it's safe to say, our #1 fan, Tammy, because Tammy has joined us for every single live stream since our very first one, all the way back in March of 2020, never missing a single week and month. So Tammy, thank you so much for being our #1 fan. We're so happy you're here whenever you join us, and it's so great to see you in the comments, of course. Got a couple of people commenting already. This is great. Got a lot of action, interaction today. Linda saying hello from Joplin. Thanks for watching, Linda. Another Linda says hello, Patrick, and everyone from Belton. Thanks for tuning in. David's watching from Parkville, Missouri. Excellent. Thanks for watching. Eric's tuning in from Lenexa. Thanks for watching, Eric. And happy birthday. Misty says hi from Gladstone. Jerry says hello, Patrick, from Hyde Park, KC. Pete tuning in from Shawnee. Jose from Topeka, and Teresa saying hi. And David tuning in from Canada. David's another name I recognize and one of our longtime watchers and supporters. Wow, so many amazing people in the comments already. And so I'm excited for tonight. It's going to be a fun stream. And before we start, and while everybody is still joining us, and feel free to keep those comments coming, we'll check back in. We're going to go through some quick announcements about the planetarium and goings on in the dome this month. And so just a little shout out to our current schedule. We do have 2 new shows for the summer. If you haven't come to visit us yet, be sure to check us out before summer's over. These shows will stay in our rotation for sure, but they're new shows that we just started showing this summer. Legend of the Enchanted Reef is an excellent animated ocean adventure where you can learn about conservation, and it's a bright and colorful show for kids and adults of all ages. And Destination Solar System is a blast-off ride through our solar system. Feels like an amusement park ride. We're flying through space in 3D. It's a lot of fun, and that comes to us from the Adler Planetarium in Chicago, one of the biggest world-class planetariums. So come check those out. We are open 7 days a week through Labor Day. So Monday through Friday, we've got a great schedule available for you. And Saturdays and Sundays, we're still open as well with a slightly different schedule. So check those out. Come visit us. Tickets are available at $8 for kids and adults. And free for kids 2 and under, and we also offer free passes with the Union Station membership. So we are excited to have you join us at the planetarium. Also, I want to shout out our upcoming evening laser shows, and this coming Saturday, we've got Laser Girl Power, which is going to be pretty great. We've got a bunch of rock and female artists, a mixtape with a bunch of different artists, all from the 70s, 80s, 90s, and today. We've got Laser Beyonce and Laser Lizzo. Those tickets are already starting to sell out, so be sure to get those tickets while they last. And then Laser Britney featuring NSYNC, which was a ton of fun when we did it during our throwback shows last month, so definitely don't want to miss that. And of course, Laser Lady Gaga to close out the night. Tickets are available. You can scan that QR code over there and buy those tickets while they last. They do sell out for our evening laser shows, so you don't want to miss that. And one last shout out, we do have an upcoming supermoon viewing event. Last month we did a telescope viewing event for the supermoon in July, but there's another one in August. That will be when the moon is closest and brightest. It's about 30% brighter than normal and 15% bigger. So we're going to set up a couple telescopes on the roof of the parking garage next to Union Station. Keep in mind that this is a member-only event. So if you're a Union Station membership and are looking to put that membership to good use, that is a special perk that we offer to only members. And if you're interested in a Union Station membership, you can definitely check out more information about that. And it includes free admission year-round to Science City, as well as free passes to the Planetarium and special discounted prices to our traveling exhibitions. So you don't want to miss that Supermoon event, August 12th, next Friday night. So mark your calendars so you can see me there with a couple telescopes in tow. All right, let's check back into the comments section. We've got Angela saying hi from the Space Coast Sunglasses. I bet it's lovely down there. Thanks for watching, Angela. Teresa is an anniversary follower. Excellent, Teresa. Thanks so much for watching and for all your support all the times you've tuned in. Debbie's saying hello from Liberal, Missouri. Thanks for watching, Debbie. Pete is all ears, ready for tonight's stream. And Stephanie says, not just Stephanie, we've got Jessany, Melanie, and Stephanie, of course, from Leavenworth, Kansas. Thanks so much for watching tonight, you all. And Linda's a first-time watcher. Thanks for tuning in, Linda. Hope you enjoyed tonight's stream. Don't forget to subscribe to us at youtube.com/KCPlanetarium, where you can find all of our past streams curated in playlists for you. Will's watching from Des Moines, Iowa. Thanks for tuning in, Will. And Dylan says, hello, Patrick from Texas. Well, yeehaw, Dylan. Thanks for watching tonight. All right, so a little overview of tonight's stream. We're going to be going over a little bit of a What's Up Star Tour, where we're going to look at what's going on in our late summer skies. And then, quickly following that, we're going to check out some current events. Oh, by the way, if you missed last month's stream, we didn't do any current events last month because last month was very exciting. We did a special deep dive stream into the James Webb Space Telescope's brand new imagery. So you definitely want to check that out if you missed that last week. We can post a link to that. We did post that on our YouTube channel, but we did a deep dive into all the new imagery that the Webb Space Telescope revealed last month, and we'll talk a little bit more about some new data from Webb today. We do have about 2 months worth of current events to catch up on because we missed those last month. So be sure to stick around for that. And be sure to keep the comments coming. Let us know where you're watching from and if you have any questions throughout the stream tonight. Now let's jump into our seasonal star tour, and we're going to bop on over to our favorite virtual planetarium software, Stellarium, and we're looking at a lovely view of our Kansas City skyline. Union Station there, a little bit of a sidebar, but we installed some brand new lights in front of Union Station recently that are set to put on a pretty amazing show, so if you haven't seen pictures of that or seen it in person, you definitely want to check that out. But we are in summertime right now, so the sun is still up here at 6 p.m., but it is starting to set earlier as we've passed the summer solstice, which is the longest day of the year, and the first day of summer, which is a bit confusing, but all in all, the sun is still up. So we want to bring the stars out, of course, so we're going to hit that fast forward button. The sun will be setting around 9:30 or 10 o'clock tonight. At least that's when the stars will be coming out. So we're going to bring those stars out and fast forward time here. And the first thing you'll notice as the sun is setting tonight is that moon. I mentioned the supermoon is coming up next Friday. That will be a full moon. So right now the moon is not full, of course. The moon is waxing. Waxing means that the moon is currently getting bigger and brighter. And right now it is in a crescent phase, so just a sliver of it is visible. But over the course of the next few weeks, it will be getting bigger and brighter, and it will be staying up later. And there, of course, as the sun is setting, we're getting those nighttime stars coming out. So we're going to be spending our little star tour here about an hour after sunset tonight. That's past twilight, where the glow from the sun is hidden. So here's about 10 o'clock, and here's our nighttime sky. Now we've got the dippers here, the Big Dipper and Little Dipper. We've talked about those previously, though, and they're up every season, so I'm actually going to skip over those. But if you come to see our live star tour at the Planetarium, you can learn all about those bears, the Ursa Major and Ursa Minor, those bear constellations. I always forget the... I always forget the keyboard shortcuts for this. Alright, nope, I just want to look at one of them. There we go. Alright. That's a little more like it. Alright, yep, so there are those bears, Ursa Major and Ursa Minor. But I actually want to focus on a different set of constellations in our northern sky. First, we have this little W-shaped constellation. This little zigzag here is named Cassiopeia. You'll be able to see it towards the northeast right now. And then above Cassiopeia is a little house-shaped constellation. And this one is named Cepheus. So let's go ahead and pull those up there. Now, Cepheus and Cassiopeia were the king and queen of an ancient African nation. The Queen Cassiopeia was very beautiful, but she was also very vain. She liked to brag about her beauty and stare at herself in the mirror. One day, she boasted that she was more beautiful than the daughters of Poseidon, the Greek god of the sea. And when Poseidon heard about this, he was not very happy. So he punished them by cursing their land with years of flooding, which washed away many of their crops and sent their kingdom into a terrible famine. Now, Cepheus and Cassiopeia tried to appease the god Poseidon and ease his wrath, and to do so, they decided to sacrifice their own daughter to the sea god. And their daughter's name is Andromeda, and she's a constellation that will be rising as we approach fall. Now, she is down here. Now, they tied their daughter Andromeda to some rocks by the ocean so she could be eaten by Cetus, a giant sea monster, and one of Poseidon's other children. Parents of the year right there. But luckily for Andromeda, the story does have a happy ending because a famous Greek hero named Perseus was flying by that day on his winged horse Pegasus, and he decided to save the day. He rescued the princess, and of course, Perseus and Andromeda fell in love, got married, and lived happily ever after. But the reason I wanted to show you these constellations is because Andromeda shares its name with a deep space object called the Andromeda Galaxy. Now, deep space objects are often only visible through powerful telescopes. They're often so faint and so far away, there's no chance to see them with the naked eye. But there are some that are visible to the naked eye. And near Andromeda's waist, there's a little faint patch of light, a little dim smudge that you may be able to barely make out, especially if you get far away from the bright city lights. And this is the Andromeda Galaxy. Now, the scale might be hard to imagine here because we're so zoomed out, but the Andromeda Galaxy, if it were brighter and you could see it more clearly, it would be 6 times as wide as the moon in the evening sky. So this is the closest spiral galaxy to us. We kind of call Andromeda our big sister galaxy. She's twice as big as our galaxy, the Milky Way. She contains over 1 trillion stars, and also Andromeda is traveling towards us. It's on a collision course with the Milky Way, but don't worry, we got about 4 billion years before that happens. And even when our galaxies collide, they won't really crash into one another. They'll just kind of mix together, and most of the stars won't even get close to one another. All right, we've got a couple people commenting on Pete, who is loving the view of the moon. Well, Pete, if you're around town, then you should check out our view of the moon through a telescope, which will be available next Friday when we do our supermoon viewing event. We've got Stephanie saying thanks for the shout out. The kids wanted me to share with you that they met you on a field trip. Oh, awesome. That's so great. Well, hello. So glad you guys are watching and tuning in tonight. Eric says, the constellations you talk about, are they primarily Greek or Roman legends? Eric, that's a great question. So the question was about the constellations, whether they come from, what sort of mythologies they come from. And, sorry, I'm getting sidetracked because I just realized for some reason the direction labels have disappeared. Oh well, we won't worry about that. So Eric was asking about where constellation mythologies come from. And let's go ahead and just pop the constellations back on. There we go. So most of the constellations in the northern hemisphere come from Greek mythology, but the constellations in the southern hemisphere are more related to navigation. They were kind of adapted from later sort of European and American explorers. And I actually did a whole live stream about star cultures and where they come from, and not just our modern star cultures, but star cultures of Africa and Asia and the Native Americans. And I did a whole live stream on the Southern Hemisphere. The Southern Hemisphere live stream was our 33rd live stream on July 27th, 2020. And then I also did ancient Roman mythology at some point, or ancient Western astronomy, and that was on February 15th, 2021. I also did ancient European astronomy, Celtic and Irish and things like that, February of last year as well. So a lot of different live streams. There's even a playlist that organizes all of our sky culture live streams, and I can maybe even post a link to that. There's this. If we can share that link to our Sky Cultures live stream, that will answer all your questions about where these stories come from. So thanks for asking, Eric. Great question. All right, Pete is saying, wow, so amazing, that galaxy. Yes, the Andromeda Galaxy is quite beautiful. And it's pretty amazing how close it is to us, and, you know, just out of reach of our human eyes, because it is so big up there in the sky, we just can barely see it. All right, so moving right along, and desperately trying to figure out how to turn the, oh, there they are. Ha, there are directions. Not that I needed them, but I figured it'd be helpful for you all. Let's actually, I'm going to rewind because we've gone a little bit late, so we're back to about 10 o'clock here. I'm going to go over to the east. Normally I don't go this direction, but over in the east, we have a bright point of light that might look a little different to you. Now, hopefully you can see in the stream, but the stars are twinkling on our software here, just like they twinkle in the real night sky. And the reason stars twinkle is because they're so far away from Earth that by the time a distant star's light reaches our atmosphere, all the gases in our atmosphere causes that little speck of light to become distorted, making it appear to kind of wobble and twinkle. But not everything in our night sky twinkles. Now there is a bright point of light rising in the eastern sky in the early evening tonight that you'll notice is not twinkling. And this is much closer than distant stars, so more of its light is reflected back towards Earth, and it's not disrupted by our atmosphere, at least not as much. And so this point of light is actually a planet, and it's the planet Saturn. Now we can zoom in on our software here to see the planet Saturn. And we're not going to take too much time to talk about Saturn today, but I do want to mention that right now during our live star tour, the Planetarium, we are flying to Saturn in 3D and exploring its rings and moons, so be sure to add that to your list. But if you do notice that bright point of light rising in our eastern sky tonight, that is the planet Saturn. And again, you can tell it's a planet because it's not twinkling. You can also tell it's a planet because it won't be in the same place every night. Planets, they appear to wander around our night sky as they orbit the sun at their own pace. That's actually how they got their name. The word planet means wanderer in ancient Greek. All right. So, back to our comments. Teresa says, I mostly look for aliens in the star. Well, good luck, Teresa. Keep looking. Somebody's got to do it. David saying, have you ever covered ancient Egypt astronomy? Do you have any thoughts on Marvel's Moon Night? Ooh, good question, David. I did cover it a little bit during my African culture live stream. We covered it very briefly. That was back on June 15th, 2020. But in terms of Moon Night, I did just see Moon Night. And I do actually remember while I was watching it, without spoilers, there was one scene that was showing the motion of the stars overhead, sort of fast-forwarding their motion, and the exact direction of how the stars were moving, and sort of the kind of wobble that was happening, because they were fast-forwarding through thousands of years. There was actually some astronomical truth to that. The night sky is not quite as static as a lot of people realize. Obviously, the stars appear to be spinning because the Earth is rotating, but the Earth also wobbles a little bit, just like a toy top wobbles when you spin it around. And there are other motions that the Earth's its orbital path changes, so sometimes it's more circular, sometimes it's more elliptical. So it may not have been perfect. I didn't, chart the stars and measure their distance, but I remember watching that scene and thinking to myself, wow, they actually depicted the proper motion of objects in the sky, not just sort of an easy, cheap CGI trick. And I think it showed the proper motion of the stars too, because all the stars in our sky are orbiting the Milky Way at their own speed. So over the course of tens of thousands of years, this constellation shapes actually morph and change. And I think, if I remember correctly, they depicted that too. So David, thanks for asking about that. And Pete is commenting that planet means wanderer. Didn't know that. Awesome. Yeah, that's a fun fact, Pete. All right, so there is Saturn. I do want to highlight up in our eastern sky. Actually, it'll be kind of closer to overhead for most of the night. There's a bright set of 3 stars that form a nice big triangle. This triangle is called the Summer Triangle. It's an asterism, so an unofficial star pattern, but it was a tool that some people used to kind of time and track the changing seasons. Now, in this constellation, which is the constellation of Lyra the Harp, what button is this one? I don't know why that one's there. All right, there it is. In this constellation, between these 2 stars that are part of the Harp, there is a deep space object called the Ring Nebula. Now, the Ring Nebula is a planetary nebula, which is the remnants of a dead star, and this image is a little bit blurry, and we have some slightly better images, but I wanted to highlight this because one of the images that the James Webb Space Telescope took and they released as one of its first images was of another planetary nebula in the southern hemisphere, and its imagery was much more beautiful and breathtaking. I can show you a little tease of that. So this is the Southern Ring Nebula. So again, it's what we call a planetary nebula, which is a stellar remnant. The gas and dust from an ancient star is slowly getting blown away as the star dies and finishes fusing all of its all the fuel in its core. So again, we did a whole live stream last month about all the images that the James Webb Space Telescope revealed, so be sure to check that out. But we're not going to spend too much time there. Just wanted to highlight that there is a planetary nebula in that constellation. All right. Let's move along, and I want to get over to our current events. So I'm just going to highlight a couple more constellations and the Milky Way. Now, summertime is the best time to view the Milky Way because in the summer we're facing towards the center of our galaxy where it's denser and brighter. So I just want to highlight, so you make sure you get out stargazing before fall and winter, because then the Milky Way will be a little bit harder to see. You can find the Milky Way by looking for this teapot shape here. There's the teapot's handle, its lid, and spout. That teapot's part of Sagittarius, the centaur. But the teapot's spout points towards the center of our galaxy, so you can kind of use it to find the Milky Way there. We also visit the center of the Milky Way during our star tour at the planetarium, so be sure to come check that out. All right, so those are some highlights of what's going on in our evening sky this season. But we are going to move briskly along to our What's Up updates for what's been going on in current events in astronomy. So everybody stick around. If you have any questions about what's going on, be sure to post those in the comments. Well, we're going to change gears here, and we are going to do, of course, our monthly segment of Webb Watch. What is the James Webb Space Telescope doing? I mentioned we've already shared all about the James Webb Space Telescope's first images they released, but now we're starting to get some scientific discoveries and data from these images and from other science. So here is a paper that has been published. Now that is a lot of sciencey jargon, but I do want to highlight the name. Sometimes scientists can be creative. The name of this scientific journal post is Panic at the Disks. And this is a study of the Webb Space Telescope's first deep field image, which let's pull that back up. So the very first image that Webb revealed is this one right here, and it's a deep field image that's zooming in on a bunch of galaxies that are very far away, so far away that they are way back in time, since their light takes so long to get to us. And we're actually looking at galaxies that were existing around the beginning of the universe. So what this paper is showing us is that these scientists were studying the galaxies in this image. You can see some of their. Oh, well, there's the image right there. Should have just shown that. Basically, they were looking at light that was being emitted from these galaxies, and they were studying their redshift. So, one thing we know about the universe is that the universe is expanding, and because it's expanding, the farther away you look, things that are moving away from us, their light is kind of shifted because of the Doppler effect. Now, the Doppler effect happens in anything that travels in waves. That goes for light and sound. So you're probably familiar with the Doppler effect when it comes to ambulances or fire trucks. When ambulances drive by you, their sound starts as high-pitched, but as they pass you, their sound lowers in pitch because the sound waves were being compressed as they traveled towards you, but now they're stretched out as they travel away from you. This effect sounds like wee woo wee woo wee woo wee woo wee woo wee woo. As it passes by, they kind of go down in pitch. Light does the same thing, though. So when we look at a galaxy really far away, its light is going to be shifted in its spectrum because it's traveling away from us. So they were looking at the redshift of these galaxies, kind of studying all of them and separating them out. And they essentially found that, they discovered a couple things. For one, they were cataloging and counting these galaxies. They're also looking at the types of galaxies. And this particular study revealed that there were a lot more spiral galaxies than we originally thought would be out there. Spiral galaxies are like the Milky Way or Andromeda, and basically they've counted over 10 times as many spiral galaxies as they originally estimated, or that Hubble had originally detected. So this suggests that these complex spiral galaxies that we see populating the universe today were actually prevalent all the way back at the beginning of our universe. So here they are studying those galaxies. A couple pictures of them. Speaking of old galaxies and redshift, I was talking about that before. Another study was studying the redshift. And this one was looking at the age of the galaxies in that image. And this one doesn't have as many pretty pictures, but essentially they were looking at the data from the Webb Space Telescope, and just a few days after Webb's first images and data were published, these scientists discovered galaxies that were present less than 400 million years after the Big Bang. But just a few days after that, so just actually about a week or so ago, astronomers discovered that they found even older galaxies, and they found a galaxy that existed around 230 million years after the universe popped into existence. So again, by calculating and measuring the shift of the light from these galaxies as they're traveling away from us, we can calculate their age, and we've basically found the oldest galaxy ever. This discovery is really exciting, and it's going to help scientists answer questions about how many galaxies we should expect to see at different points during the Big Bang, and we can learn about the evolution of galaxies as our universe itself evolved. And researchers are starting to estimate and figure that galaxies stars may have started to form as early as 120 million years after the Big Bang, and they definitely formed at least 200 million years after that. So here are some pictures of those really old galaxies, and it's just crazy that by taking a picture of deep space, we can essentially look back in time. We've got Jose in the comments saying the stars at night are big and bright. Thank you for that. A little poetic aside there, Jose. All right, another bit of Webb news, and don't worry, this bit of news has a happy ending, but there was a micrometeoroid impact back in May, but the Webb team announced it in June. So there was a microparticle that impacted one of Webb's primary mirror segments And the initial assessments of the telescope found that the spacecraft was still performing exceptionally well, though the effects of the impact were noticeable in data from Webb. So micrometeors are they're extremely small, dust-sized, fast-moving space debris. So a particle of dust is not that harmful, but if it's traveling at tens of thousands of miles per hour, it can definitely damage sensitive instruments like the instruments on the Webb Space Telescope. And so NASA announced this and then, of course, reassured everybody that Webb is still working fine. Quote, with Webb's mirrors exposed to space, we expected that occasional micrometeoroid impacts would gracefully degrade telescope performance over time. This is Lee Feinberg, who is the Webb Telescope's optical telescope element manager at NASA. Since launch, he said, we have had 4 small measurable micrometeoroid strikes that were consistent with expectations. And this one, more recently, that is larger than our degradation predictions assumed, so slightly larger than they assumed, but everything's still working fine. They designed Webb to experience many of these micrometeoroid impacts, as well as other optical and thermal, electrical, and mechanical issues, so that Webb's science mission could last many years after its launch. There are larger events like meteor showers that could be a bigger bother to the telescope, but for those, NASA's able to kind of turn the telescope and orient it away so that it doesn't get hit by those. So the Webb team is well prepared for all the events and conditions that could happen at Webb's current location and its Lagrange point. We've got Jamie tuning in saying hi from Ruth and Jamie. Thanks so much for watching, both of you. I appreciate you tuning in. Stephanie says, is one of your friends an astronaut? Stephanie, I wish I had astronaut friends. I do know a few folks who work at NASA. In fact, we have some former Planetarium staff people who are working for NASA, so that's pretty exciting. Shout outs to Jordan. All right, so other news in our local sort of Earth and orbit. Here is a Russian news article that we could probably translate. There you go. Oh, I didn't like that. Well, I'll translate for you. Essentially, there have been updates about Russia's relationship with the International Space Station, which you can take my word for. Oh, there we go. Haha. All right, so on July 26th, Russia's space agency head Yuri Borisov raised some alarms about the International Space Station partnership when he told the Russian President Vladimir Putin that Russia would end its partnership with the station after 2024. And these comments come as NASA and other partners continue their plans to extend the space station operations through 2030. Now, Borisov took over as head of Roscosmos, the Russian space agency, just a few weeks ago on July 15th, replacing the previous administrator who was dismissed by Putin. But just days later, on July 29th, a few days ago, Borisov was interviewed again by a Russian news network, which the write-up is here. And essentially, he emphasized that Russia would leave sometime after 2024, but not actually in 2024 itself. So he kind of eased some of those tensions. Borisov said, quote, we stated that we intend to do so not from 2024, but after 2024. He said Russia would abide by intergovernmental agreements for the International Space Station partnership that requires countries to provide at least 1 year's notice before withdrawing, so they can't just leave in the middle of the night, essentially. So again, this write-up, this is from Russia's news agency, and there's, I think, a video interview as well. But industry sources outside of Roscosmos speculate that, or not just speculate, but sources say that the Russian Space Agency have privately advised NASA that Russia is not really planning to withdraw from ISS before it starts launching its own modules for its own Russian orbital service station, which is their state space station that they're planning on building and launching, but they're not expecting to launch anytime before 2028. And Borisov, their administrator himself, said that, quote, radical restructuring of Russia's space industry may be required to improve production of future space vehicles necessary for their station's development, and not to mention all the sanctions currently on Russia due to the ongoing international conflicts. So translation, Russia is probably not going to be building their own space station anytime soon. Ergo, they're probably not leaving the International Space Station anytime soon. Russian officials, they claim that they plan to pull out because of rising maintenance costs and lack of new scientific dividends from the aging station, but NASA officials, in contrast, have emphasized that there is abundant time and science left for the venerable space station that's been up there for over 20 years now. All right, so that does it for our Earth and Orbit segment. We're going to move on to what's going on in the solar system. Don't forget, this is a live stream, so if you're watching, let us know where you're watching from. And if you have any questions, be sure to put those in the comment section. We've got a few more news items to cover, but we will be wrapping up sometime in the near future. That's right, I may actually keep it below 1 hour this time. So let's check in with our solar system updates, and we do have a few solar system stories, but they're pretty much all about Mars. A couple news items about the red planet. So we're going to bop on over to Mars and talk about the Mars helicopter Ingenuity. Now, a bit of not necessarily troubling news, but just a general update. Space is hard, and we are operating robots, some flying robots, on distant planets, and Ingenuity has come into its first major hiccup, I would say. There has been an issue with one of its navigation sensors, which has grounded it for the time being. The sensor in question is called an inclinometer, which is supposed to measure gravity before the helicopter begins its takeoff procedures. It's important for Ingenuity's navigation computer. In other words, the busted inclinometer means the helicopter can't orient itself relative to the ground, which is a pretty important skill for a helicopter. It's important for a helicopter to know where the ground is. Usually you want the ground to be below you when you're in an airplane. Now, like I said, this is notably the first major technological hitch that Ingenuity has dealt with since it landed on Mars in February of last year with its parent rover Perseverance. And it served its original purpose, which was really just as a tech demo. It was going to do 5 short flights that weren't really going to be collecting science, but just to demonstrate that it was just possible to fly on Mars. But it was so successful that it's flown 28 times in total, and it was actually retasked for a real purpose, that it's been actually scouting future routes for Perseverance to drive around, allowing it to navigate around certain obstacles. So it's actually doing something useful, and hopefully it will be able to continue working. Now, have no fear, because Ingenuity's team has already planned, has a plan in place to repurpose a few of the helicopter's other instruments as a hacky way of sort of impersonating the broken sensor and returning it to flight capabilities. And due to NASA's obsession with being overprepared, the patch to do just that was actually pre-written before the robot ever left Earth, so they just had to click one button and it was already set to go. Currently, though, it is dust season on Mars, so there's more dust in the air and less sunlight to recharge Ingenuity's batteries, so it's still grounded, but flights are expected to resume at the beginning of this month, so stay tuned for that. Speaking of Mars seasons, here's kind of a fun thing that you all can participate in. So the landscape of Mars is pretty rocky and barren, but the planet's skies sometimes hold clues to its past, and that's in the form of clouds. That's right, Mars has clouds. Mars has a new program called Cloud Spotting on Mars, and this is a citizen science project. So let's bring it over here. Citizen science is when real scientists offer citizens, regular people, scientists, or even normal people to participate in science. Often these are big crowdsourced projects going through large amounts of data and just putting human beings to task so that real scientists don't have to spend time sort of clicking and doing all this. And these are tasks that you can do, but computers can't really do very well. So this citizen science project is going to let the public be part of some new research that the agency is conducting to study what happened to Mars's atmosphere, which is now much thinner than it once was. Geologic evidence on Mars indicates that the now barren planet was once home to coursing rivers and expansive lakes, which leads scientists to believe that the planet's atmosphere was much thicker long ago. Today, NASA estimates that the Martian atmosphere is only about 1% as dense as Earth's, but scientists aren't sure how it ended up that way. It was probably a lot thicker in the past. So with cloud spotting on Mars, this program here, the public has access to over 16 years of atmospheric data from the Mars Reconnaissance Orbiter that was launched in 2005, and NASA hopes that this project will both educate the public on Martian meteorology as well as allowing scientists outside NASA to piece together how Mars' atmosphere has evolved. So the way this works, and again, we can post a link to this for you all to check out. But this citizen science project here is going to let you help, again, NASA scientists identify clouds. So this will be a little bit of a tutorial, but I've read through this before, and I can show you that essentially what they're looking for is you're looking at some raw data. So not necessarily pictures of the sky, but actually data that's collected and produced as a graph, essentially. And these sort of loopy spikes indicate clouds. And so essentially, what they're having our citizen scientists do, what you can participate in doing, is looking at this data and identifying these spots that are likely clouds. And so this tutorial, which I suggest you read through yourself, shows you what to look for and how to identify these clouds and what things are probably not clouds. So essentially, you want to look for very obvious double-sided peaks, so 2 legs and a peak, they say. And then it gives you some tools to sort of adjust your view. So we can try that now. So we've got this picture here, and there are a few different sets of data from the same image. And you can even invert the picture to help you see, and I can already see what looks like a spike here. So I see a loop right there. And we can zoom back out, and I can go ahead and add an arch peak marker. So I just marked where that arch peaks, and I can look at the other data, and maybe I'm thinking this one over here looks like another likely cloud form. So I've identified 2 of them. So I'm going to go ahead and continue to the next one, and ooh, this is a good one. I see 2 peaks over here. So I can hide the previous marker and mark that one there. So look here, and I'm not too sure about these ones over here. I might leave that blank just because I'm not sure, but I can identify that. So if you're bored and you're watching TV or something, pull up your laptop or iPad and help scientists catalog clouds on Mars. So as the public submits these findings, you curious hobbyists out there can help NASA sift through 16 years of data to help piece together Mars's atmospheric history. And this is just another great way to get people involved in NASA projects. And this website, Zooniverse, actually has a bunch of different citizen science projects if you wanted to get into things outside of just astronomy. So check it out. You can make an account, and there's like a score system and things like that. So it's a really fun way to participate in science and do real science. This is really real stuff that scientists, real data that scientists use. So check that out. And as NASA gears up to return to the moon soon, the cloud spotting on Mars project is an awesome way to jumpstart the public's fascination and interest in our solar system. All right, y'all. I have one last news piece, so if you have any comments or questions, be sure to post those soon, because we are going to be wrapping up in the near future. Speaking of which, David is asking, why do humans need to spot these clouds instead of machine learning? And that's a great question, David. And there definitely could be applications with machine learning and AI to potentially help identify those clouds. And these types of projects may move towards that direction in the future. But it's still important for scientists to have sort of that human touch, and it's important to be able to compare these AI models to human models. In fact, some of this data may be used to train future AI models to identify these clouds. So you need a starting point. In fact, every time you do the "Am I a human or not?" check on logging into something, that often is helping train an AI model. Or reading a CAPTCHA, one of those weird squiggly word things, that helps machines learn how to read. So this could definitely, this type of data, your help could help machines speed up this process. So that's an important step in the process, but it always starts with humans. But David, that's a great question. Thanks for asking that. All right, so one last bit of news I wanted to share. The James Webb Space Telescope is real hot right now, but it's not the only piece of equipment that's doing science. And there is a really excellent mission called Gaia, and that is actually from the European Space Agency. Gaia is a spacecraft that's actually orbiting at a Lagrange point, similar to the James Webb Space Telescope. And it has been, it was launched in 2013, so it's been doing science for a while, but a big update just happened because the third set of data from Gaia was just shared. And so Gaia is the European Space Agency's mission to create the most accurate and complete multi-dimensional map of the Milky Way. This allows astronomers to reconstruct our home galaxy's structure and past evolution over billions of years, and to better understand the life cycles of stars and our place in the universe. So this is Gaia's third release of data, and it contains new and improved details for almost 2 billion stars in our galaxy, which sounds like a lot, but we calculated there are probably over 500 billion stars. So, you know, we're getting there, but we're less than 1% cataloged. But still, 2 billion is quite a lot. So the catalog, which includes a lot of pretty pictures, but also includes a lot of awesome data. It includes new information, including chemical compositions, stellar temperatures, colors, masses, ages, and the speed at which stars move towards or away from us. That's their radial velocity. Also in this data is the largest catalog yet of binary stars, thousands of solar system objects such as asteroids and moons of planets, and millions of galaxies and quasars outside of the Milky Way. Pretty cool stuff. Now, I'm actually going to pull up a different website here that shows these images in a little bit better detail. So let's look at some of these here. So this is a really cool image showing us the motion of objects in the Milky Way. And essentially this is, well, like I said, it's called radial velocity. The red shows the regions where the motion is moving away from us, and the blue is where the stars are moving towards us. We call this proper motion. I mentioned that before. But it looks like a beautiful picture, great phone background. But this is real data. This is showing us the motion of stars in our galaxy. Here's a chemical map of the Milky Way. This is showing us what stars are made out of, their primordial material. So we can look at distant stars and learn about the different chemicals that created them. And we can see stars that are closer to the center of our galaxy are richer in heavier metals than the stars farther out towards the edge. One of the other surprising discoveries that came out of this data, I don't think we have a picture of it, but I'll just pull up another picture here. This is another data set showing us the motion of stars. But one other thing that Gaia detected is something called starquakes, which is pretty cool. These are tiny motions on the surface of stars that change the shape of stars, which is actually something that the Gaia Observatory was not originally built for. But previously, Gaia found radial oscillations that causes stars to kind of swell and shrink periodically while keeping their spherical shape. But Gaia has now also spotted other vibrations that are more like large-scale tsunamis on the surface of stars. So these non-radial oscillations change the global shape of the star, and they're harder to detect because of that, but starquakes tell us a lot about stars, notably their internal workings. And Gaia is opening a gold mine for astroseismology, which is a fun new area of study of these massive stars. So all this data, especially the data showing us what stars are made of, it can help us tell us about these stars' birthplaces and their journeys afterwards, helping us to understand the history of the Milky Way. Just pretty cool. Just wanted to share that Webb is not the only thing producing new science, and the European Space Agency is doing a lot of amazing science as well. So here is an image showing an artistic impression of the Milky Way and overlaying the sample data from Gaia's release. So you can see it's just a small part of the entire Milky Way, but still we learn a lot about our place in the universe thanks to that data. So good job, Gaia. Alrighty, James is saying, I love your background. Thanks, James. Glad you enjoy it. Casey says, hello, Patrick, and fellow Planetarium fans. Absolutely, Casey, and thank you to everyone who is watching and a fan of the Planetarium as well. And Otavio's tuning in. Thanks for watching, Otavio. Says, great info sharing, Patrick. Well, thank you so much for watching. We're going to start wrapping things up here, folks. Thank you so much for tuning in to our monthly What's Up live stream. I hope you enjoyed tonight's stream. Don't forget, you can find all of our past streams on our YouTube channel, youtube.com/KCPlanetarium. That includes last month's stream, all about the James Webb Space Telescope. Please come to the Planetarium, though. We are open 7 days a week, and we are starting to showcase some of that Webb Space Telescope data. In fact, starting soon, I'll give you a little teaser, We're going to be checking out Stephan's Quintet, the new data from the Close Galaxy cluster that is pretty amazing. So be sure to check out our live star tour for all the new updates from the Webb Space Telescope. And don't forget, next Friday is our supermoon viewing event. If you're a Union Station member, you can reserve your spot now. We're going to look at the moon through a telescope, which is pretty incredible. Oh, I should mention that we'll definitely check out Saturn as well, because it'll be up that evening too. So if you want to see the rings of Saturn with your own eyes, you don't want to miss that event. But for now, I'm going to be signing off. We will see you next month for our September stream. We'll give a little tease of what's going on in our fall night skies then. For now, though, I've been your Planetarian Manager, Patrick Hess. Thank you so much for all of your support. Thank you to our supporting sponsor, MRI Global, for keeping this program and many others at Union Station going. Hope you all have enjoyed tonight's stream, and I hope you all have a wonderful rest of the month. We will see you all next time. Bye, everybody.